Hey guys, welcome back to another ARIA-SK coding tutorial, and in this tutorial I'm going to be explaining how to use BigInt in JavaScript when the usual number data type hasn't got enough memory allocation or magnitude to support your needs. So we'll just call this BigInt. And yeah, if the name doesn't really suggest it, BigInt is basically just another data type in JavaScript which allows you to store massive numbers, but they can't be fractional. So if you somehow manage to get a fractional part, such as when you're dividing, then it's just going to be removed or truncated, as they say. So I'll just call this script.js. And yeah, okay. So let me first show you guys what a BigInt actually is. So in JavaScript, we have the regular number type, which is pretty much used all the time. I can't extend it anymore, so let's just call this a number. And yeah, this is the default type it takes when you just assign any kind of number, so it can be an int, a float, anything like that. So let's just we have a number such as 100, and if we print this, you'll see of course we do get our number just like so. We get 100 just like this, but what you'll notice is this actually comes with some limitations. So if I want this to be an absolutely huge number, let's just say we want it to be 3 times 10 to the 100. Let's see if it can handle that. And so you can see it's already got some kind of errors here. The floating point accuracy is missing. But yeah, so it's managed to represent it using standard form, but it's missing a lot of accuracy. And if this was slightly more complicated, then it'd lose all that accuracy. The same thing is true for decimals. So if we try and have a number with more than 17 decimal places, then it starts to lose a bit of accuracy. You can see it's just missed everything after the 4, it hasn't even rounded it. So you can see like when you can start to run into trouble using the regular JavaScript number data type because it's just doesn't have enough scope. That's where BigInt comes in. So it can't really help too much for pure fractional values, but what it can do is if we do something like this, what it can do is it can just store numbers. So let's just call this a big number, and it can just store huge numbers in a form like this. Let's see. Okay, yeah, so VS Code is giving us this warning, but luckily we're putting it into the BigInt function, so that's fine. But yeah, so but you do actually need to put it in quotation marks, I believe. So now what you can see is we've just passed it in as a string, but it's going to return an object which is a BigInt. So let's console.log this big number, and you're going to see we now get the large number. It's not actually that big, but see how we ran into issues above with this number not having enough decimal places. Well, what we can do is we can just multiply it by the number of decimal places it has to just convert it into this big number. Then we can just do our usual transformations on this like it was a regular number. Then we can scale it back down to have this when we need it. And that's what's great about BigInt, is that it can store an arbitrary size of number. So you can see if I just like add in way more digits, let's just add in, I don't know, let's just add as many as I can. You can see BigInt will still manage to handle it completely fine, because the way it handles numbers is completely different. If you know about CPU architecture, you'll know that most calculations are carried out on ALU, and that's where computer does all of its number stuff, but BigInt does all of its calculations in software. So it's almost like it's splitting up this massive number into smaller numbers and just using it like that. So this actually has no theoretical limit, whereas a regular number can go from I believe it's 2 to the 32, has space for 2 to the 32 digits, I believe, something like that. And yeah, once this is the maximum we can store. Actually, you can just find it by doing console.log number.max value. Yeah, here we go, max safe integer. So yeah, here's the max safe integer. Any number bigger than this, and it can't really store it safely. I wonder if it has a minimum. Yeah. Oh yeah, and it's just the same thing in negative. So a number like this wouldn't be able to be stored using the regular number type. So anyways, now that we have our big number, it's actually really easy to use. There are a few limitations, so we can't really use any of the math functions since these take in a number data type. So if we try and put this in, it's not going to really give us an error here, but it's going to give us an error when it's trying to run it because it's not actually the same data type. Although it is similar, it's not the same. But you can do all the basic operations, so you can create another big number. We can just do something like big number plus, and then we just have to create another one. And I'm just going to pass in a string like so. And yeah, you can do this, you can do plus, minus, multiply, divide, and you can also do exponentials, which is really cool. So let's see how big this other big number is. It might actually be quite slow though. Yeah, oh, okay. And yeah, you can see how quick, well not quick, but you can see how it was able to handle this massive number absolutely no problem. If we had done this using normal numbers, so let me just demonstrate. It's actually going to throw an error, I believe. Let's just raise this to the 213th power, and we will console.log this number. And you can see that when we use the regular number data type, it just gives us infinity, because to JavaScript this huge number is basically the same as infinity. So yeah, you can see the use cases of BigInts, how if you're dealing with huge data, then this could be really useful. Again, you can still do regular comparisons, so you can do if big number is greater than let's just say 10 to the 100, which it probably is. We'll console.log bigger than 1 Google. I don't know how you spell it. I'm just going to leave it like that. And yeah, okay. So you can do regular comparisons. You can also do equality checks and things like this. But yeah, if you're going to use a triple equal sign, this is not actually going to work for if you put in a normal number like so. So this won't work. But if you just use a double equals, then it'll be fine. So that's good. And yeah, thanks for watching. That was how you use BigInt. It's basically all comes down to using this function and passing it in as a string, because I believe if you try and pass it in as a number, it may still work, but it'll be a bit buggy. So it's always good to pass it in as strings, because yeah, so it still works, but for safety's sake you can pass it in a string. If you can't, then you can always just use numbers. It's not going to make too much difference. One thing you might notice is the n at the end, and that literally just denotes that it's a big int. So that's what denotes this type. It's not going to affect any of the calculations at all. You can see if I instead add 1 to this plus BigInt 1, it's still going to be completely fine. You can see that was a 4 and now it was a 5. So that n doesn't really do anything, it just shows it's a big int. But thanks for watching, and I'll see you guys in a future tutorial. Bye.